All right, this is the third FRQ for the 2014 AB exam. So here they gave you a graph of F, and then they're asking a bunch of questions about G. And that's because they gave you this part down here, which is the second fundamental theorem of calculus. And so we need to make sure that when we evaluate G, we use this. And then we need to make sure that if we want to use this graph, that we use this to figure out what this graph is in terms of G. So first, not too bad, they just want to know what G of 3 is. And G of 3 is the integral from -3 to 3, f of t dt. So we need to look at the area from -3 to 3. And from -3 to 0, that's going to be 1/2 times 3, 1, 2, 3, 4 times 4. So that's an area of 6. For this, we're going to have 1/2 times 2 times 4. So that's 4. And then here, we're going to have 1/2 times 1 times 2, which is 1, but it's a -1. Okay, so we've got 6 plus 4 minus 1 is 9. So G of 3 is 9. All right, now they asked on the next question for where G is increasing and concave down. For us to know that, we're going to have to get some more information, which means we have to figure out how F relates to G. So I'm going to use the second fundamental theorem of calculus and say G prime of x is f of x times 1 minus f of -3 times 0. And that goes away. So G prime of x is f of x. And so that means that this graph of here is the graph of the derivative of G. So if I want to know where the graph is increasing, that means that I'm looking at the parts of the derivative that are above the x-axis. And if I want to look at the parts that are concave down, then I need to look at where the derivative itself is decreasing. The derivative is decreasing right here, and the derivative is decreasing right there. And so that means that G is going to be increasing and concave down on the interval from -5 to -3, and then the interval from 0 to 2. And the justification for that is because G prime of x is positive and decreasing. All right, part C says h of x is g of x divided by 5x. And they want us to find h prime of 3, so I'm going to do the quotient rule to find the derivative. So I've got low d high minus high d low divided by low squared. And then I can go ahead and plug in 3. So G of 3 we already found is 9. G prime of 3 is -2. So if I plug in 3, I get -2 to the derivative graph. So I've got 15 times -2 minus 9 times 5 over 15 squared. I'll write 15 times 15. So you can leave it like that. If you want to simplify it, what I did is I realized that I could take out a 15 here, I can take out a 15 here, and I can take out a 15 there. So if I take out the 15, to take out 15 from this piece, I need to think of the 9 as 3 times 3. So there I took out a 15, took out a 15. So I had negative 2 minus 3 over 15 is negative 5 over 15 is negative 1/3. But you should have been good here. All right, and then part D gives you P of x is f of x squared minus x, and they want the slope of the tangent line where x equals negative 1. So P of x is f of x squared minus x. P prime of x is the derivative of the outside, keep the inside the same, multiply the derivative of the inside. And then we're going to be plugging in negative 1. So I've got f prime of 1 plus 1 is 2 times negative 2 minus 1 times negative 3. So f prime of 2 means we're going back. I'm going to erase this and say, okay, instead of thinking of it as g, I'm saying, okay, this is the graph of f. Now I need the slope of that graph when at an x value of 2. So an x value of 2 here is here. What's the slope of that graph? Well, at this point, it's going down 2 over 1, down 2 over 1. So the slope here at 2 is negative 2. So I'm going to say that this is negative 2 times negative 3. And so that derivative evaluated at negative 1 is 6.